Good morning, students. I am going to start the second lecture, that is the refraction through refraction through rectangular glass slab. Refraction through rectangular glass slab. Okay, refraction through rectangular glass slab. Now let us suppose it is a rectangular glass slab. Is it clear? It is glass slab. So there are two, we can say the surface. This is the first surface and it is the second surface. This will be air, this will be air, and it is the glass. It is glass. So let us suppose a ray of light and the thickness of this glass is T. Now let us suppose a ray of light is incidenting on the upper surface of this glass at point A. So it is the incident ray. At point A, it is the normal. Since in this case, light is coming from rarer medium to denser medium, so it will bend towards normal. And again, it is incidenting at point B on the second surface. And when it is coming from glass to the rarer medium, the reflected ray will deviate away from the normal. It is incident angle I and it is angle of reflection R. Since this line and this line are parallel and it is intersecting, so this angle will also be equal to R. And ray of light in this case is emerging out from the glass slab. So I am saying it is angle of emergence and indicated by E. Now look here. It is the first surface of glass slab and it is the second surface of glass. The speed of light in air is c, whereas in glass is v, and in here is c. Apply the Snell law. 1 mu2 will be equal to sine I upon sine. In term of velocity, 1 mu2 will be equal to c upon v. At the first surface, the speed of light in first medium is c, whereas the speed of light in second medium is v. So 1 mu2 will be equal to c upon v. And on the second surface, I am writing here 2 mu1 will be equal to v upon c. It is equation number 1 and it is equation number 2. Multiply equation 1 into equation 2. What we get? We get 1 mu2 into 2 mu1 will be equal to c upon v into v upon c. This will be cancelled out. Finally, we get 1 mu2 into 2 mu1 will be equal to 1. Means the refractive index of second medium with respect to first medium into refractive index of first medium with respect to second medium, the product will be always equal to 1. Is it clear? Means whenever a ray of light is coming from air into a medium and again emerges into the air, the product of 1 mu2 into 2 mu1 will always equal to 1. Now, this is, I am assuming it is equation 1. Now look. So, we have derived one formula that 1 mu2 into 2 mu1 is equal to 1. Now, look. What is Snell's law on the first surface in the form of angle of incidence and angle of refraction? So in this case, 1 mu2 will be equal to sine I upon sine R. It is the refractive index at the first surface, and at the second surface, 2 mu1 will be equal to sine R upon sine R upon sine E, because it is the refraction. So I have written E. Is it clear? Now, 1 mu2 into 2 mu1 will be equal to sine I upon sine R into sine R upon sine E. This will be cancelled out. What is the value of 1 mu 2 into 2 mu 1? 1 mu 2 into 2 mu 1 is 1. So I am keeping here 1. 1 will be equal to sine I upon sine E. This will come here. It will come here. Sine E will be equal to sine I. So E will be equal to angle I. Means angle of emergent will be equal to angle of incident. And it is the emergent angle. So these are the two very important derivation. One is the 1 mu 2 into 2 mu 1 is equal to 1. And whenever area of light is coming from here and again emerges into the same medium, so in that case angle of incidence is equal to angle of emergence. Is it clear? Now look, we have to see the next topic we have to see is lateral shift. So we are going to see the lateral shift. I am writing here lateral shift. Lateral shift. Let us suppose it is a rectangular glass slab of thickness, and the thickness of this slab is T. A ray of light is coming from air at a point A on the first surface. So whenever this ray of light will come, and as we know that it is air, it is glass, and again it is air. So we know that when a ray of light comes from rarer to denser medium, the refracted ray will bend towards normal. So it is refracted ray. And when it is incidenting on the second surface at point B, and when a ray of light is coming from denser medium to rarer medium, it will deviate away from the normal. This is angle of incidence I, this is angle of refraction R, so it will also be angle of refraction R, and this will be angle of emergence. Now look, if there is no any rectangular glass slab in path of this incident ray, so in that case what happens? In that case this ray will follow this straight line, means this incident ray without deviating will follow this straight path. But since we are keeping a rectangular glass slab in the path of this incident ray, so it is deviated and emerges in this direction. So what is the lateral shift? Lateral shift is a perpendicular distance between this incident ray and this emergent ray. So I am drawing a perpendicular, and this perpendicular is, let us say, M. Means BM is the perpendicular on A, and this distance is known as the lateral shift. Means in this case I am writing here BM is lateral shift. BM is lateral shift, and I am indicating this BM by S. Now look here. Since this ray and this ray are intersecting at point A, so opposite angle will be equal to each other. Means this angle will be equal to this angle. So this total angle will be I. Since this angle is R, so this angle will be equal to how much? Tell me. I minus R. Means if we are considering this angle, so this angle will be equal to I minus R, and it is angle R as well. Now I am taking triangle ABM. What will be the value of sine I minus R? Value of sine I minus R will be equal to perpendicular upon hypotenuse. This side in front of this I minus R will be perpendicular, so perpendicular will be BM, and hypotenuse, this angle is 90 degree, so this side AB will be your hypotenuse. So sine I minus R will be equal to Bm upon AB. So Bm will be equal to AB sine I minus R. And this Bm is the lateral shift and is indicated by F. Now look, in second triangle that I am taking here, second triangle, I am drawing a perpendicular. This perpendicular is N, means AN is the perpendicular on BN. So I am taking the triangle A, N and B. A and B. This angle is R. So what will be cos R? Cos R will be equal to base upon hypotenuse. This side will be perpendicular and this will be hypotenuse. So this AN will be base in triangle A and B or ABN. I am writing here cos, the value of cos R. The value of cos R will be equal to AN upon AB. So from here AB will be equal to AN upon cos R. Since AN is the thickness of this rectangular glass slab and we have taken the thickness is equal to how much, tell me, T. So this will be T upon cos R. Now I am putting this value AB in equation 1. So B lateral shift or X barabar BM will be equal to T sine I minus R upon cos R from equation 1, and it is your equation. So this is the lateral shift, that is T sine I minus R upon cos R. Is it clear? So write it down. Okay, students, after studying this topic, that is the lateral shift, we have to see, I am writing here again the new topic, that is the apparent depth. Apparent depth. Is it clear? So the next topic will be apparent depth. Apparent depth. What is apparent depth? Look here. Now let us suppose it is a path. Now we have to see the apparent depth. Now let us suppose it is a bucket in which the water is filled up to this side. It is the water level, and this is the surface of water. And there is an object which is kept at bottom of this bucket at point O. Means it is a object. It is object which is kept at point O. Now look here. Since it is, I'm writing here, it is water. So what happens? Look here. We know that this is the object which is kept at the bottom of this bucket, which is filled with the water, means water is present above this object. The image of this object will form, and how the image of this object will form? Look here. One ray of light I am just emitting in the direction of normal, so it will not deviate because it is incidenting along the direction of normal. So it will emit in a straight line without deviating. And second ray I am incidenting at point A. It is point A. It is the normal. In this case, light is coming from denser medium to rarer medium, so it will deviate away from the normal. It is angle of incidence I, and it is angle of reflection, say R. So look, since this ray and this ray are parallel to each other, and one other thing, this reflected ray is moving in this direction and this reflected ray is moving in this direction. Either they will intersect or not, they will not intersect. Where in this direction. Understand? So I am just reversing this reflected ray. It is intersecting at point, let us say I, to this reflected ray. It is point A and I am saying it is point B. So in this case, this ray and this ray are parallel to each other and this ray are intersecting. So if it is angle I, so this angle will also be equal to I. This and this ray are parallel to each other and this ray are intersecting. So if each angle is R, so each angle will be also R, corresponding angle. Now, I am checking two triangles. We are seeing two triangles. So I am checking two triangles. One triangle is OAB. So triangle OAB. What will be value of sin I? The value of sin I will be perpendicular upon hypotenuse. The side in front of this angle, that is AB, will be perpendicular. Means here I am writing here AB and the hypotenuse will be equal to, tell me, this is 90 degrees. So this side will be perpendicular in triangle OAB. And in this case, hypotenuse is equal to how much? Tell me, OA. Means AB upon OA. I am taking an approximation. Approximation OA. If this point will lie very near to this point B, so in that case OA, we can consider OA will be equal to OB. So I am taking here one approximation, means OA will be nearly equal to OB. So sin I will be equal to AB upon OB. It is equation 1. Now take another triangle. This triangle is BIA. BAI. In this case, I am calculating the value of sin R. Sin R will also be equal to perpendicular upon hypotenuse. The side in front of the angle will be perpendicular. Means here AB will be perpendicular and hypotenuse will be equal to, tell me, IA. Again, I have taken consideration IA will be nearly equal to IB. So it will be AB upon IB. Is it clear? Now, what is refractive index? Apply the Snell's law. Refractive index is mu is equal to, light is moving from which medium to which medium? Look here. Light is moving from denser to rarer medium. In this case, we are observing that light is moving from denser to rarer medium. So I am writing here D and here R. It will be equal to sin I upon sin R. Put the value of sin I. So it will be D mu R. Put the value of sin R. Sin I will be equal to AB upon OB. And this will be equal to AB upon IB. Will be cancelled out. So D mu R will be equal to IB upon OB. IB upon OB. Is it clear? But what we know, my dear students, since this is the refractive index of rarer medium with respect to denser medium. So I am writing here equation 1. From equation 1, since we have D mu R into R mu D is equal to 1. So R mu D will be equal to 1 upon D mu R. So I am keeping the value of D mu R here from equation number 1. So it will be OB upon IB. It is the refractive index. What is the OB? OB is the distance of the object from the surface of water. Means this is the real depth. And what is BI? BI is the position of image from the surface of this water. So this is the apparent depth. Means mu will be equal to real depth real real depth upon apparent depth. Is it clear? And if we want to calculate the 60 OI, so what will be OI? OI can be written as OB minus IB. Take OB as a common. This will be equal to 1 minus IB upon OB, and it will be equal to OB in bracket 1 minus 1 upon mu. This is the OI, which is known as the apparent shift will be equal to OB. Let us say I am given that thickness of this water in the bucket is T. So T 1 minus 1 upon mu. Is it clear, my dear students? So this is the relation between apparent depth and real depth. Understand? And this is the formula for the apparent depth. Dear students, now we are going to see the total internal reflection. What is total internal reflection? Look. Let us suppose it is denser medium. It is denser medium and it is rarer medium. A ray of light is moving from denser medium to rarer medium. So it is incident ray, which is incidenting at point O, and it is the normal. It is normal. So we know that when a ray of light moves from denser medium to rarer medium, it deviates away from the normal. It is angle of incidence I, and it is angle of reflection R. As we increase the incident angle, the deviation from the normal of this reflected ray also increases. So in this case, I am a little bit increasing the incident ray. So this deviation will also increase from the normal. At certain angle, the reflected ray emerges parallel to the surface. This certain angle at which reflected ray emerges parallel to the surface is known as the critical angle. Means I am incidenting this ray, and this angle is critical angle, that is psi. And in this case, the reflected ray emerges parallel to this surface. So this angle is known as the critical angle. Means critical angle is an angle at which critical angle is an incident angle at which the ray of light emerges parallel to the surface. Means at critical angle, at I is equal to IC. What is the value of angle of reflection? Means at critical angle, I is equal to IC. What is angle of reflection? Angle of reflection is 90 degrees. So what will be Snell's law in this case? Snell's law will be equal to, this angle is 90 degrees. Snell's law will be equal to, light is moving from denser medium to rarer medium. So this will be D and this will be R. It will be sin I upon sin R. So D mu R will be equal to sin, we put the value of I, that is equal to IC upon sin 90 degrees. What is the value of sin 90 degrees? The value of sin 90 degrees is 1. So from here we get D mu R is equal to sin IC. Means the refractive index of rarer medium with respect to, the refractive index of rarer medium with respect to denser is equal to sin IC. But we know that R mu D will be equal to 1 upon D mu R. So this will be 1 upon sin IC. Sin IC. It means the refractive index of medium mu that is R mu D is equal to 1 upon sine IC. So what will be sine IC? Sine IC will be equal to 1 upon R mu D. So IC will be equal to sine inverse 1 upon R mu D. This is the critical angle. This is known as the critical angle. Means critical angle is an incident angle at which reflected ray emerges parallel to the surface. Now, if little angle increases greater than this critical angle, what happens? When we increase a certain amount of angle greater than the critical angle, the ray of light emerges into the same medium or reflects back into the same medium. This process is known as the total internal reflection. Total internal reflection means when a ray of light moves from denser medium to rarer medium, at certain incident angle, the reflected ray emerges parallel to the surface. But when we increase the certain amount of incident angle greater than the critical angle, the ray reflects back into the same medium. This process is known as the total internal reflection. Because in this case, total ray of light is reflected back into the same medium. No ray of light is moving in rarer medium from to denser medium. When we increases the angle greater than the critical angle. Is it clear? Now, what is the application of total internal reflection? The first one that we have to see is mirage. Which application we have to see? Diamond. We know about the diamond optical fiber, and the fourth one is after optical fiber, that is prism. Also acts on the principle of total internal reflection.